Hi, friends. Okay, so hello, everyone. For those of you not physically here, it's a huge crowd and you're really missing out. Today we're going to talk about build process and optimization as relevant to your final. And you're going to start with just that concept, what happens when you type make. So if you looked into your make files, they're very cryptic, scary. But there are basically 3 steps to taking a code from C code to an executable. The first step is the preprocessor. The second step is the compiler / assembler, but I didn't want to do 4 because there's only 3 Pokemons. And then the last step is the linker, the linking process. The preprocessor is a pretty dumb process that follows directives that start with a hash symbol. So when you pound define a constant or you pound include file, what it does is text substitutions, and it removes comments, processes macros that you define using a pound defined. If you say pound include, that's just text substitution of a header. Like if you say pound include some header file, that'll just paste in the text of the header file. If you can run just the preprocessor, and you'll see that the output, while funky looking, is actually valid C code. It's a little hard to read because all of the nice little macros that you use, like null, for instance, that'll actually get replaced with like 0 cast as a pointer. So it'll be hard to read, but it is valid C code that the preprocessor outputs. The next step is the step that does, as far as 107 is concerned, the compiler does the hard work. So it will, first of all, it'll enforce syntactically correct code. So if you say, x equals 4 without saying int x equals 4, the compiler is the one that's going to catch that because it's looking to build an abstract, this is a little bit above the level of 107, but it's looking to like put together the meaning, like this if statement contains multiple statements, and it's trying to parse out those statements. So it's going to enforce syntactically correct code. And then it will output a .o file. And the build process will go on to the last step, which is the linker. So let's say your function calls printf. And you didn't write printf, you just put include stdio at the top of your file. So the preprocessor, it included the prototype for printf, then you used printf, but the actual implementation of printf is off somewhere in a standard library. And the compiler, which just processes one file at a time, doesn't know anything about the implementation of printf. It just looks to make sure your prototypes match, or your call matches the prototype, and says, okay, we just assume printf is implemented somewhere and it works. The linker is what actually resolves that reference and puts in the address of printf for that spot in the code so that it goes to the library implementation of printf and does the right thing. Does anyone have any questions just about the basic? Yes?
The .i file is valid C code?
Yes. Yeah.
The file's not doing anything. The link is going to do all 7 processes. The file's not going to do that stuff.
Yes. Any other questions? Just about preprocessor, compiler, assembler, linker. One thing that's a little confusing when you talk to people is that this whole process is referred to as compilation, but then they'll say that the stage 2 is the compiling stage. So that's just a confusing naming convention that you can be aware of. Okay, so for those of you in my lab, you may have seen this little table before, but we're going to try to figure out which stage these errors are caught at. So the very first, if you guys have pen and paper, it might be useful at this point. Try and predict where things are going to get, where errors are going to get caught. So that first mistake in the code would be if you misspelled the word define. This one you might not need a pen and paper for that very first one. Do you know what would catch that? Preprocessor, compiler, linker? No, any guesses? You got a 1 in 3 chance of getting it right. Preprocessor, yeah. Because the preprocessor is just going to sort of, all it looks at is things that begin with hash. So it's like, okay, there's a command for me, and then it's like, oh man, I don't recognize that word. So see how it responds. Yeah, if you go to compile that, it'll say invalid preprocessing directive, #define. Okay, so the next one is, well, we wanted to define x as this string constant, but we left off a quote. Does anybody have any ideas whether the preprocessor or the compiler would catch that? Yes, Lindsay? The compiler, why?
I think in the preprocessor, it will just replace all the x's with the quote test, but it won't realize that that's a problem.
Yes. Yes, exactly. The preprocessor is like, okay, you told me to replace all x's with single quote and then the letters T-E-S-T. I'll just do that. And then the compiler has to deal with the fact that the code now has an open quote and no close quote, or a closed quote somewhere totally incorrect, followed by something that doesn't make syntactic sense. Oops. So we actually get a warning from the preprocessor, which is like, are you sure? But it does it anyways. And then the compiler, I think in the code that I wrote for this one, it was the only quote in the code, so it just said, well, there's no close quote here, so I can't process that string. Okay, #include with a file that doesn't exist. Who catches that? Preprocessor? Yeah, the preprocessor, its job to go to that file, paste in that text, and if the file doesn't exist, then it can't do it. So it gives a really dramatic error for some reason. I noticed this was different from other errors. It says fatal error, compilation terminated. So a little more drama there. Okay, so a missing type, what I mean when I say that is like, if you have a for loop and instead of saying int I equals 0, you say I equals 0. So who would catch that? The compiler? Yeah, because it's looking for types to match up, make sure that you declare all your variables before you use them. How about if you used a function that exists, but the prototype wasn't at the top of the file? So you guys have done this before. You have a function definition somewhere at the bottom of the file, but then you call the function before the function definition with no prototype at the top of the file? Yes. So you actually get a warning, which I told you guys there would be an error, but there's no error if that's the case. It just warns you and moves on. It goes ahead and compiles and links read all fragments to the right function. What if the code is missing? We know this can't run if the code is missing. So you have a prototype, but there's no code anywhere for that function. Yes?
I want to go back to what are the implications of that warning?
Of this warning? So the compiler is saying, hey, I noticed that you used a function that you didn't give a prototype for, and I guess what would be useful as a coder is that maybe you misspelled that function and that function actually doesn't exist. But there's another case where you just called a library function that totally exists and you just didn't feel like writing the function prototype or including the header file for that library function or something. So like if I said, you guys recognize this function from assemble. So if I had perfectly warning-free code in reassemble, and I made a call to read all fragments, but I misspelled it. I said read all fragment or something. It would say, hey, I see you're calling a function that, there's no prototype here. The compiler can't see into the future. Maybe the linker is going to, link that call to an actual function definition somewhere. But the compiler is sort of noticing that there's no prototype around for that. It can't check the types. It can't check that you put the right arguments in there. Does that help?
What I meant is, I understand how I can generate that warning. What I'm interested in is, if there is that warning, you just go on anyway, the linker's going to solve the problem. Suppose I don't have a prototype, but the function is
Yes, then you can go on anyway.
then the linker will solve the problem.
The linker will solve the problem. However, you're just going on faith that you called it correctly, that you use the right types of input and the right return value. So, yes.
So then, in theory, if you didn't prototype anything, your program would still run.
Yes.
Okay.
I'm like, yeah, I think
Then
so.
why would we prototype?
Because you would like the compiler to tell you, hey, this function takes 2 ints and you gave it 3, or, check types and yes.
So basically, it moves your errors to compile time rather than runtime errors, right?
Yeah.
Okay.
Good questions. I hadn't thought about them too deeply. So, any other questions about that? The next one I want to talk about is missing function code. We know this wouldn't run. You have a prototype. The implementation doesn't exist anywhere. There is a prototype, but that code doesn't actually exist anywhere. Exactly, yeah. So it passes by the preprocessor, passes by the compiler checks that your types match with the prototype, and then it gets to the linker, and the linker is like, there's nowhere for me to go to find that. Okay, these last two, missing constant, I mean, if you defined X, or if you did not define, capital X, or something that, you meant to be a pound defined constant at the top of the file, if you just forgot that line and used it anyways. So I'll give you a hint. It's exactly the same as one of the other cases. Or actually, I don't think I put the other case. No, I did. It's exactly the same as one of the other cases on here. As far, yes.
Maybe the same as the top one.
Is the very top one? No, the very, what are you thinking?
Is it the same as second? Because
The open quote test?
Yeah,
No, actually, so this one, the directive define doesn't exist, so the preprocessor noticed that right away. We'll notice that right away. The second one, open quote test, the preprocessor can follow through with that, and then the compiler, there's bad code, or rather there's something that looks like a string literal and is not. What it's actually the same as, so let's think about how the code would end up going. So you meant to put pound define x5, but you didn't, and then you went in the code and you used x. That's the same as this row right here. As far as the fact that it's in all caps, the compiler doesn't care. That's just for readability. As as far as the compiler is concerned, you just introduced or you just started using a variable without declaring it. So they have the same function there, or the same error output. Okay. Similarly, what if you had a macro like all caps min that took 2 arguments and output the minimum, but you forgot to define it and you used it anyways? That would be the same as one of these other errors too. The
Like it's going to be a compiler error for sure, right?
right.
No exactly or output error.
Okay, let's take a look at it. So it's actually a compiler warning. The compiler will notice that there's no prototype. So again, it doesn't care that it's all in all caps. It doesn't, like, that's just for human readability that we put macros and constants in all caps. So it looks for a prototype for the function min. It doesn't find one. It says, hey, I didn't find a prototype for this, but I'm just going to pass this problem onto the linker. Maybe it's somewhere, and you just didn't prototype it. And then the linker says, it can't find min. Yes?
So you can link against macros as well.
Link against macros?
Like, meaning that like what you have here is that, like you're saying that it's a possibility that like a macro could be defined somewhere else, right?
So if you don't put define, no, a macro, it could be defined in a header file, and then you could use it. But the point is here that, it looks like just, it's the same as if you said lowercase min. It would just be like, that's a function, I guess, calling it like a function. Okay. Any questions about this table? Yes?
In the linker column, is an undefined reference an error or a warning?
That's an error. And that should make sense that it's an error. If you literally did not write the code for a function and it doesn't exist anywhere, there's no way that your code could execute. Yes? Yes, the preprocessor says, like, its job is to follow things that begin with a hash, and it can't. So it just gives up right there.
What's the difference between like a missing macro and a missing constant?
A missing macro, I don't have an example, nor do I have a whiteboard. But if you look at the top of, trying to think of some starter code that might have it. A macro is where usually you'll see it in all caps. It'll say define capital min as this little tiny function where the preprocessor basically goes in and pastes the text of the function. So there's a tiny little function that's just done by substituting in the definition that you put at the top of the file. So it'll usually be some little thing like min or max or, I don't know, things that would be okay for like inline text substitution. And it'll substitute in the proper arguments, but that's the only difference between that and defining a constant. And a constant is literally, please cut this and paste that. Any other questions about this table? Yes?
For the missing constant and missing macro, how will the compiler know that it's like a constant or macro if you've never defined it?
Exactly. That was why these are the same as like this warning and error is the same as this one. Well, not quite the same because it's completely gone there. The compiler doesn't know that it's a macro. It just sees that you have a word followed by parentheses with stuff inside, and it can't, a macro is never pasted in. And so the best it can do is say, well, I guess this is a function. The compiler looks for a prototype and doesn't find one, so it gives a warning. And then the linker can't actually find a function that matches that.
So it's the parentheses that seem like this is supposed to be a function.
Yeah, I think if you have a word with parentheses and things in it or not things in it, it'll be interpreted as function. Yes?
So to clarify, so if we have min there, but we put in parentheses input, then the compiler would give us an error rather than a warning in that situation, an extra stop compilation?
No. So if you had min, and you would call min with 2 inputs. So if you had min x, max frag length here.
Sorry, yeah, put that way. Max frag length, put parentheses around that one. Now I just get a warning.
Yes, so if you put parentheses after max frag len, the compiler would assume that it was a function that didn't have a prototype, and it would move on, and the problem would belong to the linker now. Cool, all good questions. Yes, Ethan?
This is assuming that before max frag length it says either an int or void star or something like that to define what type it is.
No, these are uses of the thing. So these 2 examples are we tried to use something and never defined it. So maybe like with min, you might do something with the return value, but you don't have to use a function. Yes?
So equivalently, I'm just at the time. If I take it, it does have parentheses, it's equivalent, and I delete all that, and then this compilation will stop at that.
Yes. It'll say undefined variable min, or first use of undefined variable, or something like that. All right, we're going on. We're going to talk about common optimizations. So on the left, I have these little inane functions that I wrote. And what I'm first going to show you is totally unoptimized code. There's a lot of stack activity here because it is not using registers efficiently. But what I want to focus on is, like, how does it handle the math in here? For instance, in this function, I'm converting hours to seconds. And you guys know that that is a pretty easy task, and I'm making it really hard in this function. I'm defining seconds per minute to be 60. I'm defining, oops, minutes per hour. Oh, I can't change that because it's a screenshot. Sorry, everyone. So that should be minutes per hour. Oh, no, that's seconds per hour. Right. So I'm defining seconds per minute to be 60. Seconds per hour is 60 times seconds per minute. And then the number of seconds is hours times seconds per hour. This is a very long-winded way of multiplying the input by 3600 and returning it. So we all know by heart that imul is an expensive operation, right? That's more expensive than addition or shifting, or like the only thing, like division's more expensive than imul. But we kind of want to avoid it. So imul gets called here and here. All these intermediate variables get set up, and this ends up, it ends up calculating all 3 of these things. So does anybody have an idea about the obvious way to optimize this? Yes?
Do all of the multiplication in one line, so you don't have like multiple.
Yeah. Seconds per minute only gets used as something to multiply by 60 to get seconds per hour. So if we take that constant, seconds per minute, and we just get rid of it and put a 60 here, that's equivalent, right? Because seconds per minute, that's the only place it ever got used. And then if we could even take this constant here and just drop it right there. So this is not really super smart. It's just, well, this thing only ever gets used here. This thing only ever gets used here. So you see, this is also a little bit iterative. You have to start at, I couldn't immediately say, well, I guess I could paste that in there. But if I start at the top, then I have a constant. I put that in there. I see that this is a constant, and I can put that there. So let's look at the slightly optimized code. Just did it all in one line. One imul, it pre-calculated the 60 by 60, multiplied the input, and returned it. The important thing is that this is called constant folding. So when you see that the compiler replaced constants and maybe got rid of earlier versions of constants, or if one constant is only ever used can be used in multiple places too. Basically, plugging in a constant and then getting rid of its declaration. That's constant folding. Combining them. Okay, we're going to do one that's a little tiny bit more complicated. So this function doesn't do anything useful. It takes the number of hours that you input, converts it into seconds, subtracts something. In the other line, it divides it by something. It adds those two values. How many times is imul called here? 2. What's one way to optimize this? I know there might be more than one way, but just one way to optimize it. Do you see a way to only call imul? Yes.
Cache the 3600.
Exactly. Yes. So we do it once and we stash it. And then we take that value and we subtract something or we divide something. But yes, if you cache something so that you only have to do it once, that's called common subexpression elimination. I don't believe that you have to memorize the names for the final, but just know that all of these are possibilities for optimization. Okay. This next one, which is kind of cool. So the function I wrote takes a number, squares the number, checks if the square of the number is less than 0, and if so, it prints the unicorn thing, otherwise it prints the tangerine thing. The unoptimized code has jumps in it. Like, we don't have to go into all the details, but it tests something, it jumps to L5 if the thing is true, or if the thing is greater than 0. It jumps to L, or it keeps going through and does this print otherwise. So there's definitely jumps in there. That's expensive. What do you guys think about this function? Yes?
It's always going to print routing tangerines.
Yes. The square of a number is always positive. So
What about overflow, though?
that's a good question.
Because you could overflow to any number and then print routing tangerines.
Yeah. I encourage you to try that. But the compiler, if you set it to if you set it to 01, it doesn't change this. But if you set it to 02, it changes it to that. So all this function does is print rotting tangerines are real.
So it wouldn't be right, though, if you're, like, if I wanted to write a function which would detect overflow, like, it would detect whether a number squared is overflow, right? Then this code, like, then this optimization is wrong, right?
Aren't you relying on undefined behavior then? Like,
No, right? Because I know when a number is, like, any number that's larger than the square root of int max will overflow to a negative number, right?
so you're relying on the value of int max, right? Which, well,
But the function takes int as an argument.
yes.
I should be able to, in theory, be able to write a function, right, which detects whether a number would be overflowed if it goes squared.
Yeah. I actually kind of had this discussion with myself earlier, and I didn't test it out, but this is a valid optimization. This is an actual optimization that happens. Yeah, let me make a little, after lecture, I'll make a little example, and we can play with it. Like what happens when you actually overflow an integer.
Yeah.
So the if statement never gets reached. The else statement gets printed every time. And so the optimization is just delete the code we don't use. Get rid of the jump. We always do this tangerine thing. That's called dead code elimination. Okay, this one, I could not find a compilation that didn't optimize this. No compiler is going to say IML, even at 0 optimization. You guys know what this is going to do? Take your input, multiply it by 7. We don't want to multiply because that's expensive. Yes?
You can shift by 3 and then subtract 1.
Exactly. You want to multiply by a power of 2, which is going to be a bit shift by, so if in the case of 7, we would multiply the number by 8 because that's 2 to the third, and just subtract off the number. So there it is, a super slick one-liner. This is called strength reduction. So when you see division or multiplication get turned into like 2 additions or multiply by a power of 2 and subtract or something like that, taking a more expensive operation and making it into a couple less expensive operations. What optimization is this? This for loop prints this. If I put 7 into this for loop, it would print 49 7 times. You guys cool with that? That's what it does. However, it is going to, I only see IML once here, but if you inspect this, that IML is inside the loop, which means that it's going to happen 7 times if I input 7. What do you think? Move it outside the loop. Yes. Yeah. This is the only one I bothered to circle anything on. So since num doesn't depend on I, it doesn't change inside that loop, we can calculate it outside the loop, save it, and just use it every time we iterate through the loop. Moving code to a more efficient place is called code motion. I feel like it sounds like a crappy company from the 90s or something. But it's literally just like you move code, that's code motion. Okay, here's another one. This code prints the word knock and the word knock. It's a tiny loop. The unoptimized code just makes a tiny loop. There's the jump, compare, and jump, and calls. Have you guys seen the function puts? That's like printf, but if you just want to spit out a string literal, you don't want to do any fancy formatting or anything. Yes.
I have a quick question about code motion.
Yes.
Is there ever a case where it's not like loop hoisting?
I think that is called loop hoisting.
Oh, so the same thing.
Yes. Code loop hoisting is in the Venn diagram inside code motion. Yes. Yes. Pulling something out of a loop so you don't have to do it multiple times is called loop hoisting.
Would there ever be a case where like it didn't involve like for loops?
Yeah. Not that I can think of. Yeah, we can twiddle around with the compiler later, try to find something where it would move the code. Okay, so we have a branch and a compare and a jump, and like maybe we could do this a little bit more efficiently. Does anyone have any ideas for yes? Could unroll the loop, yes. So when she says unroll a loop, what she means is just paste the code twice. So no need to do a jump and compare. Just call puts twice. This is, yes?
Is there a point where
Yes.
It'll be fine.
Yeah, I think when I was making these, it wasn't that long. It was like 5 or something.
Oh, really? And I just decided since the recording is better.
Yeah, like I just like played with different numbers and.
Oh, really? Even at higher optimization, does that?
I was using optimization level 1.
Okay.
Yeah. That's called loop unrolling. Okay. Does anybody have any questions about compiler optimizations? Yes.
How should we expect to apply this knowledge
On the final? Very superficially, right? You guys didn't do optimizations. You didn't write compilers. So you're expected to recognize that it is correct for a compiler to do loop unrolling or constant folding and not be like thrown off by the fact that maybe it threw away some intermediate values when it was doing constant folding or something like that. Yes, Ethan?
When it turns a recursive function into a loop or something else, does that fall under one of these categories, or is it something different?
Tail recursion to iteration or something like that. Yeah, I didn't do that one because I thought I haven't seen the final, but I thought that I would rather not go into something that complex, and it also doesn't happen very often. But yeah, that is called like what he's talking about is there's an example I think you saw in class where she wrote code for a factorial calculator that was recursive. So it would like peel one off and pass, like if you said factorial 7, it would say 7 times factorial 6 unless the number was 1, in which case it would return 1. So there's a recursive function, and if you optimize that, it'll turn it into a for loop. But there are not that many times that happens, as cool as it sounds and as cool as it is. Or at least not that many times in 107.
What's the rationale of turning it into a for loop?
Oh.
Because like this, making the new stack frame for the function.
Yes.
Is like much more exciting.
Yes. So you can iterate a jillion times. There's nothing stopping you from just iterating. You guys saw that lab where you did a factorial. Yeah, that's what I'm thinking of. There's a lab where you guys did a recursive factorial and an iterative factorial. And you saw that the recursive factorial actually ran into the heap, which is like terrible. And the iterative factorial just like overflowed the int and kept going. So yeah, running into the heap is a bad kind of crash. Overflowing an int, like, yeah, maybe not so bad. Also, not all iteration is like, you could have an iteration that goes forever and doesn't overflow an int. So. But recursion you'll always run out of stack space eventually. Okay, any other questions on optimizations? Did you have a question? No? Answered your question? All right. So since we have tons of extra time, I'm going to talk about an example from a previous quarter where we use the preprocessor to do some work for us. This is not like something that you'd have to be able to reproduce, but if you could follow it, that would be a good indicator that you understand how the preprocessor works. So last spring, part of an assignment we had was to detect leaks. So when code called malloc and then didn't free it, this was supposed to sort of keep tabs on that and let the client know that they had called malloc or realloc and not freed that data. So this required a wrapper. So we needed some way to monitor calls to malloc while still performing correctly. So here's a wrapper that takes in, it's just like, well, externally, it's just like malloc, right? It takes in a size and it returns a pointer to heap memory. But here's the function that monitors what just happened. So this is the function that sort of keeps tabs and says, okay, the client called malloc once for this size, and we'll keep the pointer and make sure they free that. So here, for example, like client code does whatever it does, and our leak detector code is going to watch it. But you may be thinking, like, WTF? Why would a client go out of its way to call __wrap_malloc if it's already leaky code anyways, right? That's pretty ridiculous. We would like for the client to just be able to call malloc as they normally would, and then we'll handle this, and then we'll actually do wrap malloc. So is everyone clear on what we would like to do? So we would like to be able to analyze code that is just written normally, but actually behind the scenes calls this wrapper function. So enter preprocessor. So what we'll do is we will attach a header to the client code. And the client code doesn't have to know about this. We can write a make file so that it just quietly attaches this header. And replaces malloc with wrap malloc. Similarly, of course, it would have to also replace free with wrap free and realloc with wrap realloc. So you might be able to tell me already what goes here. What goes in that header file? Yes?
Like, how to find malloc. Oh, yeah, malloc as wrap malloc.
Yeah, this header file is not going to get applied to that, so we're safe. Yeah, so there it is. And then preprocessor goes in, swaps that in, compile the code. This is what ends up happening. Then we can run it and monitor calls to malloc. Yes?
Trying to compile this, would just recognize that there's other calls to malloc elsewhere? Or they define malloc somewhere, right?
The standard library has defined, or
Oh, I see.
we're just talking about regular old malloc. We want to replace it with our malloc, and then our malloc will call regular old malloc. Yeah. Yes, Ethan?
Why wasn't keep allocator done this way so that we could just write malloc?
No comment. There is a reason. This has flaws. If you were to call fopen, which is internally calls malloc, right? You can't monitor that. Yes.
When the preprocessor has a define malloc, why, or puts it all the other lines that not replace like malloc inside wrap malloc, or is it just two separate?
They are separate. This header is going to get applied just to this file. You're right. That would be a bad time if it went and replaced that with a recursive call to wrap malloc. You would get a blazing crash, right? You'd have wrap malloc calling itself. Bad times. I thought. Was there a question over there? Yes.
I guess, so the reason why this isn't why it doesn't like recursive crash is because the pound define is only within the client.h's file.
Yes.
I thought that the pound defines existed across like if you define something in one.
So if at the top of one file you define a constant,
Define index, let's say, and I can use that in my.
I don't think so. If you included the header in the other file, I think you could.
Okay.
I did actually run this, and it
Well,
was okay. Yeah, I have. So I have a follow-up with you, and then I can follow up with you to make sure that we are on the same page about that. Yes.
You know, you said like it wouldn't track. This is flawed because like if f open like there's a malloc, but when you pound include like the library which f open belongs to, wouldn't you then like go through and replace everything in that file, all malloc with wrap malloc?
Oh, library functions are not. They're not in C anymore, right? They're already compiled code. Also, yeah, I think that is part of your question, which is, do pound defines just like go everywhere, or do they just apply to the file that they're part of or included on? And I think no. But yeah, definitely couldn't do, like a pound define is not going to work on code that's not in C. Yes?
This will only do it for the word malloc surrounded by spaces. Or like if the client had a function that was called don't malloc under any circumstances written in camel case or something like that, did it change it?
Yeah, it's pretty dumb. And so we do define malloc, and they write a function that says, don't malloc under any circumstances. It's going to go and say, don't __ wrap malloc _ malloc, or wrap _ malloc under any circumstance. That's a very good point. Yeah, this is a very hacky construction. We ended up using two versions of this. One where the preprocessor did the swap, and the other one where the linker did it, which was much cleaner. Yes?
Also applies to like comments that you have in your file, right? Like you would say like some comment that says, this function does malloc.
No.
And then it would just paste out in like the .i file or whatever, the intermediate file that would say __ wrap malloc, right?
No, it wouldn't. The very first thing the preprocessor does is get rid of comments, and it also doesn't do things that happen inside of string literals.
Okay, cool.
Or it doesn't it ignores the contents of string literals. Yeah. Yes?
Is there any way you could manually like add white space around like wrap malloc that like would be cut out so that it could look only, or around malloc, sorry, so that it could only look for the like malloc calls that begin with the space?
Yeah. So if you really were dead set on using this, oh God, it would be such terrible style. But like, you could put an open paren. You cannot do like the space is not going to work, but you could do an open paren. That's probably about as far as you could go. Yeah. Yes?
I also just remembered, you have to know about like the if not defined, if and def stuff, or because I feel like she mentioned that once in lecture. I don't know if we were like.
I don't know. I would be surprised. Is that confusing to you? Like if something has not already been defined, define it. Yeah. So that you see that at the top of your like, it's one of the hash commands is if not defined, define this thing. So that safeguards against like, let's say I include math.h and something else includes math.h. This keeps the code that text from getting pasted. Something else that I include also includes that. This keeps the text from getting pasted twice, basically. Yeah?
So even though if the .h file is in the standard library, it will copy the .h but not the .c.
And there is no .c. Well, yeah, there doesn't have to be a .c.
Oh, okay.
Yeah, the .h file full of function prototypes. And there can just be compiled code that the linker can then go and find addresses in. Any other questions? Any other unrelated concerns? You guys are going to do great on your final. And thanks for coming, even though you're, yeah?
So for the optimized code, I was just thinking like possibly about like something tell that it's the optimized code system and like like how we have to translate something back to regular code. Could we envision a case where we have to translate optimized
that wouldn't be crazy. Although, like in the example that I gave, the very first one with constant folding, yeah, if you saw this, you would say return hours times 3600. So if you were asked to go from this to code, you wouldn't arbitrarily do something more complex, even though it would be correct. It would be harder and also sillier. A for loop. Oh, if you saw an unrolled for loop, like in the knock knock example, and you translated that into print the word knock, that would be totally correct. All right. I saw one other question. Yes.
Do you know, like, breakdown of the final?
The breakdown of the final.
Yeah. Like, is it cumulative? I mean, like, is it weighted more towards the top?
The final has to be cumulative because you can't do things from the second half of the class without things from the first half of the class. I believe, Skylar, it is supposed to be similar to if you took 2 midterms and yeah, pretty much like if you took midterm 1 and midterm 2 plus a little bit. Yes.
Are all of these example questions like fair game for what a final question might look like? So could it, for example, be like we have like a table of like what happened if you didn't define a macro and you have to be like, oh, that's a compiler error?
That's a valid question, yeah. Oh, the table that I showed. I think that is totally fair game. You wouldn't have to know exactly what the error is, but you would have to be able to put a mark in the right box. Yes.
Does that also mean like you should know like what yields warnings and what actually results in an error, or is just knowing which one catches it sufficient?
The most important would be knowing which one errors.
Okay.
I feel like when I took the class, they asked me about a warning, and I got it wrong. But that might just be, huh? Okay. Okay, cool. Then I.
This may not be something you know, but is there going to be more than one practice final?
I think Cynthia's making another one. Cooking it up right now. All right, guys. That's all I got.